Go. Hey guys, this is Matt with MonsterVR. Once again, I'm doing another lesson in C# for Unity 3D out of this book called Learning C# Programming with Unity 3D by Alex Akita. Today we're going to cover order of operation. It's going to be chapter 4.7. So we're in Unity. We're going to open up MonoDevelop, which is here. Boop. And now we can get started. So variables and functions work together to make your class operate as a part of your game. As an example, we're going to move an object through space using some simple math. To use numbers correctly, we need to be very specific. Remember, computers do exactly what they're told and nothing more. Code is executed only when the function the code lives in is called. If the function is never called, then nothing in the function will run. Once a function is called, the operation starts with evaluating the code at the top and works its way down to the end of the function one line at a time. The first order, which we've been working with so far, is by line number. When code is evaluated, each line is processed starting at the top. When it works its way down, the first order, which we've been working with so far, is by line number. When code is evaluated, each line is processed starting at the top. Then it works its way down. In the following example, we start off with an integer variable and perform simple math operations and print the result. So, in the start function, tab over. There, perfect. We'll go int integer a is equal to 1. Semicolon, enter. And what we'll do is we'll go print a, bam. And we'll hit a semicolon there. And then we'll go int, actually no, it's going to be a is equal to a plus 3. Let's get that right there, right there. Oop. Perfect. Boom. And we're going to do print A again. So we'll go here. Just hit Control C, Control V, enter. And then we'll do A is equal to A times 7. And we'll do print A. Okay, cool. Control S. Save this up. All right, and then what we'll do is we'll take this class and we'll just put it on the main camera for now. We'll go here, drag this guy right there, bam. We'll go to the console and let's see what happens. Play. Ah, 1, 4, 28. So let's go back to the code. 1, so integer a is equal to 1, print a. So then we take a is then equal to 1 plus 3, which would be 4, and then print 4, and then 4 times 7 would be equal to 28a. Perfect. Okay, cool. That seems like it makes sense. Excellent. Here we go. As you might expect, the first line prints 1, followed by 4, and then by 28. This is a rather long-handed method to get a final result. However, things get a bit strange if we try to shorten this to a single line, as math operators work in a different order than we just used them. So let's try this. They say, get rid of this. Boop. And we're going to go A is equal to 1 plus 3 times 7. Cool. Ooh, nope. And then we're going to print A again. Cool. Control S, go back to here, clear this out. Let's hit play, see what happens. 22. After shortening the code to a single line in this example, we get a different result, 22, which means 3 and 7 were multiplied before the 1 was added. Math operators have a priority when being evaluated, which follows the order of precedence. The multiply and divide operators have a higher precedence than the add and subtract. When evaluating integer A, C# looked at the math operators first and did the math in the following order, because the multiplication sign, so let's go back to the code. So because of the multiplication sign here was seen as more important than the plus sign, 3 times 7 was computed, turning the line into turning the line into 1 plus 21. Then the remaining numbers around plus were evaluated, resulting a being assigned to 22, and then ultimately printing that to the console output. We'll observe the other behaviors and learn to control how math is evaluated. This section might not be so exciting, yeah. But it's worth the while to leave this section as a reference. When your calculations begin to have unexpected results, it's usually because of order of operation coming into play and evaluating numbers differently from what you've expected. So I guess this is going to be a little book time until... So, okay, we'll go into evaluating numbers. Calculation of variables is called evaluation. As we had mentioned before, each object added to the scene is Unity's 3D editor has several components automatically added when it's first created. To make use of these components, you simply use their name in your code. The first component we'll be using is a transform attribute. Transform contains the position, rotation, and scale of the object. You can see how these are changed when you select the object in a scene and move it around. You can also enter numbers using the inspector panel, or even click on the variable name and drag left and right as a slider to modify the data in the field. Moving objects around with the code works in a similar manner as entering values in the inspector panel. The position of the object is stored as 3 float values called a vector 3. Operators in C# are the tools that do all the work in your code. The first set of operators we'll discuss is arithmetic operators. Crazy. The first component we'll be using is the transform attribute. That's crazy. Okay. So I guess we're going to go into math. Let me take this off of play real quick. So that was just a small little paragraph on evaluating numbers. I guess we're going to go into math now. Let me see here. Alright, let's do this. Okay, cool. Plus, minus, divide, and multiply, and percentage. The plus and minus do pretty much what you might expect them to do. 1 plus 3 is equal to 4, 1 minus 3 is equal to negative 2. This does come as a surprise, this doesn't come as a surprise. Divide uses the backslash, putting the first number over the second number. However, the number type is important to sort out before we get too much further. So, let's go into the start function. And we're just going to put a couple debug .log, and we'll go 10, 3, .log, Wowza. Go 10F divided by 3F. Oh, sorry, I got parentheses. Cool. Semicolon. Log is not capitalized there. Cool. Let's just do this last time. Control C. Control V. All right. And then what did they have there? Oh, they just have 0.0, 0.0, and 0.0. No F's. I think these are called doubles. Don't quote me on that. All right. Let's see what happens. Control S, save, and clear, and play. All right, cool. So it looks like it did the math for us, I'm guessing. So the first line above is a 10 divided by 3, which might not return what you would expect. Writing a number without any decimal tells the compiler using integers, which will give you an integer result. Therefore, the final result is simply 3, with the remaining 1/3 cut off since it's rounded down. The second line has an F after the number, indicating we want a float value, which would be a decimal value. The third line without the F indicates a double value. This has, I was right, double, indicates a double value. This has twice the number of digits as a float, which is right here. All right. So they said, let's try going bigger numbers. We can go bigger numbers. Let's go mono develop. Wow. Okay, we're gonna do this. Oh, I already have it on there. So we'll go here, Control V, Control V. Cool. So, how many zeros is this thing? Oh, no point. 1, 2, 3, 4, 5, 6, 7. 0.0. Cool. It's breaking the computer. I love it. Yes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Cool. Let's go 0 as well. Rad. All right. Control save and let's run it. Clear. Wait. Weird. The result here shows the different number of trailing threes after the decimal. We mentioned in section, right here. Grab the code. We mentioned this in section 4.4 that there are different types of numbers. Here's an example of what that really means. An integer is a whole number without any decimal values. A float is a decimal type with only 7 digits in the number. A double is quite a lot bigger, having a total of 15 digits in the number. Doing this experiment again, the large numbers exposes how our numbers have some limitations. Yes. Like the integer, the large double and floats only have so many places where the decimal can appear. The number for the double is huge to begin with, but we should have more threes after the number than are shown with a decimal. Where did they go? Keep in mind there should be an indefinite number of trailing threes, but computers aren't good with indefinite numbers. Computers without special software can't deal with numbers with an unlimited number of digits. To show bigger numbers, computers use scientific notation like E plus 15 to indicate where significant numbers begin from the decimal point. Games in particular rarely ever need to deal with such a large number, and to keep processes running fast, numbers are limited. Cool. Software application designed to deal with particularly huge numbers tends to work more slowly as they need to run with the same limitations, but instead perform operations on the first part of a number and then another operation on the second half of a number. This process can be repeated as many times as necessary if the number is even bigger. Scientific computing often does this, and they have special number types to compensate. There are some additional number types as well as other data types that aren't numbers. We'll leave the other data types for later. The operators we're dealing with here are mainly for numbers. Okay. Man, that is a really boring section. I say we jump into operator evaluation. Okay, we'll do this. As we saw before, 1 plus 3 times 7 will result in 22. We could use the long-winded version and start with A, then add 1 to it, then add 3 to that, and then multiply that by 7 to get 24, but there's an easier way. So we're going to do this. Pause here. Wham. Go integer A is equal to which will go 1 plus 3. Oh. 3. Shoot. Spacebar is not working very well. 7. Bam. Alright. Enter. I'll go debug dot log parentheses A semicolon. Alright, cool. Hit Control S, see what happens. Play. 28. 28. Alright, let's see what happened there. So it added these together first with the parentheses and created 4 and then times that by 7, which would equal 28. That makes sense. By surrounding a pair of numbers with parentheses, we can tell the compiler to evaluate the pair within the parentheses before the multiplication. This results in 28, similar to the long-handed version of the same math. To elaborate, we can add in another step to our math to see more interesting results. So we will go into, we'll take out the parentheses. And we'll do +9. Cool. Control S. See what happens. Clear. And play. 31. Okay. 31. How about that? The code above results in 31 printed to the console panel. We can change the result to 49 by surrounding the 7 plus 9 with parentheses, like in the following. 4. It's wild. So we'll take this, we'll go put the parentheses here, bam, and bam. Control S. I'll get out of play mode, back into it. 49. There it is. Cool. The compiler computes the 7 plus 9 before the rest of the math is computed. Parentheses take precedence over multiplication regardless of where they appear. It doesn't matter where the parentheses appear, either at the beginning or at the end of the numbers. The parentheses are computed first. So whatever's in the parentheses goes first. Adding another set of parentheses can change the order of computation as well. Parentheses within parentheses tell the computer to start with the innermost pair before moving on. For instance, oh, that one's crazy. We'll go into here. I'll go parentheses 11 parentheses 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 times 2 parentheses parentheses. Okay, semicolon. That one's wild. So I'm assuming it's going to go 9 times 3, and then that's 27, and then times 2, and then times 11. 2 and then 11. Let's see what happens. Control S. Oh, and I'm not very good at math, so 594. Wow, that was a big number. Wow, that did turn it. So parentheses within parentheses. So for instance, it starts, okay, we go here. All right, here we go, cool. So the computer starts with 9 times 3. This turns into 11 times 27 times 2, which then yields 27 times 2, which turns into, so 27 times 2, which then turns into 11 times 54, and then 54 times 11 turns into 594. Boop. So that is the order of operation with the parentheses, I guess. Perfect. So at this point, you will need to be very careful about the placement of the parentheses. For each opening parentheses, there needs to be a corresponding closing parentheses. If you're missing one, then Unity 3D will let you know. It's important to have a sense of what sort of math to use and when to use it. In this case, where the parentheses encapsulate the entire expression, their presence is redundant. Taking out the first and last parentheses will have no effect on the final result. This is true for most operations, but for clarity, it's useful to know that they are indeed optional. To be clear about this, we can add any number of extra parentheses to the operation, and there will be no other effect to the final result, though it may look a bit strange. Encapsulate the entire expression, their presence is redundant. Taking out the first and last parentheses will have no effect on the final result. This is true for most operations, but for clarity, it's useful to know that they are indeed optional. To be clear about this, we can add any number of extra parentheses to the operation, and there will be no other effect to the final result. I got it. So if we just added like 1, 2, 3, 4. display. Oh, is it clear? 594. Yep, didn't do anything. So as long as you have an opening parentheses and a closing parentheses, it doesn't matter how many you use, but it just doesn't look right. So don't do that. To make things more clear, we can rearrange the expression to be a lot more readable by setting up different variables. For each set of operations, we can create a new variable. The operation begins with the first variable, then after the value is stored, the value is carried to the next time it's used. Just remember, a variable cannot be used until it's been created. So, we're going to go into here. Whoop, get rid of this. And we'll go int a is equal to blah, 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 blah. Caps lock on, there we go. Is equal to 9 times 3. B equal to A times 2. Excuse me. C equal to B 11 times 11. Cool. All right. Da 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 da. Debug.log. Oh, we're gonna do C. All right. I'll hit Control S. Save the script. We'll clear here and let's see what happens. 594. Pretty cool. That was pretty rad. In this example, we've created a different variable for each part of the math operation. Let's go back to the script. Cool. First, we created a 9 times 3 variable assigned to A, right here. After that, we multiplied A by 2 and assigned that to B. Finally, we multiplied 11 and assigned B by 11 and assigned that result to C. To view the final result, we printed out C to get 594, the same result as the long, fairly obscure operation we started with. This example shows a simple use of variables to make your code more readable. This seems like we're back to where we started with at the beginning of this section. To be honest, both methods are perfectly valid. The decision to choose one system or another is completely dependent on what you find easier to understand. What we should take away from this is the order of which the lines are read. The operations start at the top and work their way line by line to the bottom of the function. As variables are assigned new values, they are kept until they are reassigned. It's important to note that by creating more than one variable, you're asking the computer to use more space in your computer's memory. At this point, we're talking about very small amounts of memory. A classically trained programmer might want to fix this code upon reading it and then convert it to a single line. To be honest, it does take up plenty more space, not only visually. When starting a new set of operations, it's sometimes helpful to use a more drawn-out set of instructions using more variables. When you're more comfortable that your code is doing what you expect it to, you can take the time to reduce the number of lines required and do a bit of optimization. There's nothing wrong with making things work first and cleaning up things later, or cleaning things up later. So, last paragraph, what we've learned. I guess that's the end of the chapter. Therefore, you've been introduced to variables, and you've learned about functions, 2 big components of programming needed to make a game. Directives will allow your code to talk with Unity 3D and put meaning behind your variables and functions. We're using C# and Mono, which is an object-oriented programming environment. We just learned objects are all the little bits of info that make up your different C# classes. When we're done with writing some code, Unity 3D will automatically interpret your code for your game. At this point, we've got pretty strong grasp of the basics of what code looks like and different parts of how code is written. We've yet to make use of any logic in our functions, but we should be able to read code and know what it is and what is and isn't a function. It'd be a good idea, by way of review, to make a few other classes and get used to the process of starting new projects, creating classes and adding them to objects in a Unity 3D scene. Once you're comfortable with creating and using new classes in Unity 3D, you'll be ready to move on. Cool. So I guess that's going to be it for today. Next time I'm going to be looking at class scope, I believe. Let me double check. Yes, class scope will be the next time. So once again, my name is Matt with MonsterVR. Thank you so much for watching, and hopefully these videos will start getting more and more better as the more I get them done. So anyway, bye guys.